Good day and welcome back. So in this video, we are going to enter the second chapter in STPM physics, which is the kinematics. So the first topic in this chapter can be considered as the revisions of the linear motions that you learn in your STPM physics. You are required to learn how to derive and use the equations of motions with constant accelerations, and then you're going to learn how to sketch the graph of displacement time, velocity time, and the acceleration time for the motion. Let's begin with the definition of linear motions. In simple, it is just a motion in a straight line. So when you have a linear motions that has constant accelerations, such as the free-fall motions that you learn in Form 4 physics, there are 4 linear motion equations that you can use, and actually the derivations of those formulas has been mentioned in your Form 4 textbook. So this is the image extracted from your textbook, and I hope you can do your own practice to do the derivations. Next, we will go through the graph of 3 basic types of motions. First is when the object is at rest or stationary or etc. We have the ST graph as straight line graph that has 0 gradient, which means that the value of the displacement is constant and doesn't change all the time. So the object has 0 velocity and 0 accelerations. Second is when the object is in a constant velocity. So the VT graph is quite similar as the previous graph, that it is a straight line graph which has a 0 gradient. If we translate the graph into ST graph, remember that the gradient of ST graph is representing the velocity of the object. Since the object is in a constant velocity, the gradient of ST graph must be a constant value, so it is a type of linear graph. Based on definitions of the velocity, displacement of the object is changing at a constant rate, velocity is constant, and it has 0 accelerations. So for the motions with constant velocity, there's only one equation that you can use, which is the S is equal to Vt. Before we move on to the third type of motions, you can recall back what you have learned in Form 5 Physics Chapter 1. So these two motions is related to a situations where all the forces acted on the object is in equilibrium, which means that the resultant force is equal to 0 and leads to a 0 accelerations. So according to the Newton's first law of motions, the object will remain at rest or in a constant velocity when there is no external force acted on the object. So the third type of motion is of course due to the external force and cause the object is in a constant accelerations. So here the graph is also quite similar, that the AT graph has a straight line graph which has a 0 gradient, and when you translate to VT graph, the gradient of VT graph is the accelerations. So if the object is in a constant accelerations, the graph of VT is a form of linear graph. But when you translate the graph into the ST graph, it will become the graph in the form of quadratic graph. So this graph actually can be related to the equations of S is equal to ut plus half at squared. So you can see that the S is proportional to the square of the time. So compared to the previous two motions, object has a constant accelerations when there is net force or the resultant force acted on the object, such as the case of the free fall motions. The free fall motions is due to the gravity, and the object has a gravitational accelerations which is equal to negative 9.81 meter per second squared. So the negative here indicates that the directions of the accelerations is in the downward directions. Make sure you are clear with the negative signs. In short, when you analyze the motion with constant accelerations, you may consider to use one of the 4 linear motion equations that has been mentioned in the very beginning. And in fact, you use the first 3 motion equations most of the time in the question related to the free fall motions, because you will have the value of the A is equal to negative 9.81 meter per second squared. Now let us try one question from the trial paper of Sandra Institution in 2022. A ball is dropped from a window and takes 1.6 seconds to reach the ground. Which of the following is the height of the window? So to solve these questions, you need to learn how to extract information and learn how to label those values. For displacement, we will set the initial position of the object as the reference value, which is equal to 0 meter. And if you consider the outward direction as a positive directions, so you have the displacement of the ground as negative h, where h is the height of the window. And then from the questions that the ball is dropped from a window, and there is no information about the initial velocity, you can assume that the initial velocity of the ball is equal to 0. With this, we have the information of the initial velocity, the time, and the accelerations, and we need to find out the height of the window. So we can use the formula of S is equal to ut plus half at squared. So just put in the value and you can obtain the height of the window is equal to 12.6 meter. So for this type of motions, some people may consider the downward directions as the positive value And it is actually okay because the motion here is only in one direction. So let's find out another variables, which is the final velocity when the ball is reached the ground. Let's say we don't have the value of the displacement. So what is the formula that we can use to obtain the final velocity? So we have the u, a, and t. So we can use the formula of v is equal to u plus at. So put in the value and you can obtain the final velocity is equal to negative 15.7 meter per second. So the negative here indicates that the velocity of the object is in a downward direction. So now let us move into the tri-purple of Terengganu in 2022. For this time, we have a stone that is thrown vertically upwards from the height of 10 meters from the ground, and it has an initial velocity of 5 meters per second. So the question is, what is the time taken for the stone to reach the ground? So remember to learn how to extract the information and how to label those values. We have the displacement of the initial position as 0 meter. So the displacement of the ground will be labeled as negative 10 meter. So for this case, you can expect that the ball is going upwards with a decreasing velocity. This is because of the gravity and the assertions of the object is a negative value. So the object will decelerate until it reaches a certain point, which is known as the maximum height. After that, the ball will start to drop with an increasing velocity. So here we have the initial velocity of positive 5 meters per second, which is in upward directions. So we are considered the case that the stone is to reach the ground. So at the ground, we have the displacement is equal to negative 10 meters, and we have the initial velocity, accelerations, and we need to find out the time. So the suitable formula here would be the S is equal to ut plus half at squared. So this is a form of quadratic equations. So you just solve it like how we did in the mathematics. And in the end, you need to reject the negative value since the time is a scalar quantity. So the final answer for the time is equal to 2 seconds. Let's explore also the case when the ball is reached at the maximum height. So remember that the velocity at this moment is equal to 0 meter per second. So the initial velocity of the stone is still 5 meters per second. And you can do some practice to find out more information about these motions. First, you can use the formula of v is equal to u plus at, and you can obtain the time to reach the maximum height, which is 0.5 seconds. And then you also can use the formula of v squared equal to u squared plus 2as to obtain the displacement of the maximum height, which is equal to 1.25 meters. So some question may ask for the height from the ground. So you just need to add the height of the building, which is 10 meters, and you can obtain the maximum height from the ground is equal to 11.25 meters. So when you have all the informations, we can start to plot all the three types of linear motion graph. Let's start with the graph of AT graph. So it is simple that it has a constant value of negative 10 meters per second squared. And when you want to translate the graph into the VT graph, we need to find out the initial velocity, which is 5 meters per second in this case. So the ball is decelerating since it is going against the gravity, and it will drop to 0 meters per second at the time of 0.5 seconds. And then the magnitude of the velocity is going to increase until 15 meters per second at the time of 2 seconds. So here is another homework for you to find out how to obtain the value of the final velocity. And lastly, we're going to plot the ST graph. So the object will start at the displacement of 0 meter, and it will reach the displacement of 1.25 meter at the time of 0.5 second. And then it will drop to the displacement of negative 10 meter at the time of 2 seconds. And here, you also can apply the knowledge of quadratic equations that you can obtain the second time the object reached the displacement of 0 meter is equal to 1 second. So it will be quite interesting if you can find out all the values here. And that's conclude my discussion for today. If you still have any questions, you can leave it in the comment section below. Also, do leave a like and subscribe my channel. I will see you in my next video. Thank you.